of an information. Data itself is not an information that you can use, but trending them, analyzing them, making them, crunching them, you can make very useful information out of it. So, and that links me to the topic that we are going to discuss today. The session title is Asset Management and Optimization, and I would say optimization is always an inherited element in asset management, because we always talk about continuous improvement as part of asset management. So I have 6 speakers. 3 of them will be online. We'll introduce them as we go through. The first speaker is Engineer طارق العبري. He's going to talk about online condition monitoring system in Oetc. Tariq is actually the asset management or asset performance management manager at Oetc. He holds a Bachelor of Engineering in Electrical Power from SQ 2008. He also have MSc in Power Systems from the University of Birmingham in UK in 2015. He has a total of about 14 years of experience in the industry, and 6 years of them are actually in the asset management. I will welcome Engineer Tariq to the floor, to the stage, and we'll take it from there. Tariq, you have 15 minutes, and I will be counting that.
Yeah.
Thank you, Dr. Adil. So good morning everyone. My name is Tariq Al-Abri from Oetc Asset Performance Management Manager. Thank you, Dr. Adil, for the introduction. I'm going to share Oetc experience in implementing the online condition monitoring system. It was a very exciting journey, actually, having started along with Dr. Adil since he was available in Oetc. And we are continuing that journey for implementation of online condition monitoring system. So we are going to cover certain areas, and we start with asset portfolio to see the capital assets of Oetc and what is the value of that. Drivers, what drivers have driven the project of OSCM system. Then we'll cover the OSCM system design, the asset health models. We'll give an example of asset health models that have been designed in the system itself. Then what challenges we are facing and the ongoing and future plans. So I will start with the quote from Steve Jobs that let's go invent tomorrow instead of worrying about what happened yesterday. And absolutely right that we have to explore and look for new innovations that helps our business and forget what happened yesterday. We have to learn from what happened yesterday and continue developing our businesses. So in terms of asset portfolio of Oetc, as you know that Oetc is owning 400 kV system as well as 220 and 132 kV system. In MIS and Dhafar system, in Dhafar we have only 132 kV right now. Oetc is going to interconnect the north and south of Oman with the interconnector between phase 1 of the north and south interconnection. So we will be operating the full network from north to south of Oman. That is also a driver to have a monitoring system for our assets, because it will be spread out the whole of Oman, and our assets having a huge capital cost and having a huge impact if any of those assets failed, either in Oetc network and also to our economics. So in terms of 548 transformers and reactors in different voltage levels and different capacities. Also, we have 100 GIS switchgears with around 1,100 bays of GIS switchgears. In overhead line, we have around 7,611 kilometers of overhead lines across the north and south of Oman. In terms of underground cables, we have around 318 kilometers of underground cables across the different voltage levels. With huge capital investments, with huge capital cost, we have to explore different options how we can take care about those assets and ensure the reliability of those assets as well. So what is Oetc condition monitoring strategy? We have set and established a strategy for our assets as we started the condition monitoring system. So in terms of transformers, we are monitoring different aspects. We are monitoring the DGA, the dissolved gas analysis, the dissolved gases in the transformer in 400 and 220 kV transformers, as well as 132 kV, so in all the voltage levels. Also, we are monitoring the moisture in oil, the partial discharge, the bushing, dissipation factor, and capacitance. We are monitoring also the on-load tap changer, as well as the temperature, oil level, the cooling system, and the mechanical protection. So, except for partial discharge and bushing monitoring for the 132 kV transformer, that is excluded because it is less critical compared to 220 and 400 kV transformers. In terms of switchgear, we are monitoring the partial discharge. We are monitoring the gas density and quality. We are monitoring the CB number of operations, the fault current, and over voltage. Of course, this can be expanded for other signals. It can be also integrated to the protection systems where we can get the number of faults, the short circuit level, even the timing of the circuit breaker can be obtained from the protection systems. In terms of underground cables, we are monitoring the temperature of the cables, and we are planning to have partial discharge for the cables as well as for the terminations. In terms of battery systems, we are planning, still not yet implemented, but we are planning to monitor the battery systems as well. In terms of voltage, current, thermal image, and hydrogen level in the battery room as well. So how to maximize the utilization of all of these local monitoring systems? It's only by implementing the online condition monitoring systems and get all those signals. As you know that Oetc has revised its vision to be a smart grid by 2030, and OLCM is one of the initiatives that will help to achieve Oetc vision. So we have to design our assets in a smart way, we have to operate in a smart way, and also to decide on our maintenance and investments in a smart way as well. Second driver is to optimize our maintenance activities and to be smart in our maintenance decisions and replacement decisions as well. So shifting from time-based maintenance to a smart condition-based maintenance is a main driver for online condition monitoring system. Of course, using the IoT, artificial intelligence, and big data concepts that also will support implementation of the OLCM project. As an example of a cost saving in terms of implementing the new strategies for a switchgear, we have saved a lot of cost compared to the condition or time-based maintenance. Compared to the condition-based maintenance, we have saved around more than 5 million Oman Riyal since 2014 until today, which is a big amount of cost. So the third driver is the capital investment and replacement plan prioritization. The system will give us an outcome of criticality index, asset health index, which is related to the replacement of our assets, asset maintenance index in terms of required maintenance activities and the target of that maintenance activities. Probability of failure as well, we'll get it as an outcome of the system, and the estimated remaining life of our assets. In terms of system design, as you can see, we started with 6 grid stations in 400 kV level. Now it is integrated to the system with the local OLCM systems through a network infrastructure. We have 4 zones in the system. We have a production zone, infrastructure zone, DMZ zone, and quality assurance zone. Each of these zones have its own main functions. The main function is the production zone, where the grid lab and the grid ABM systems are available. The grid lab is responsible to receive all the online monitoring signals from the site and store it in a historian system that can be utilized, will be established, and the criticality of our assets also will be established. The OLCM, the beauty of OLCM is combining the offline data and the online data together. The online data is coming from the site through the sensors. However, the offline data is coming through the testing and the maintenance activities that being carried by OETC staff. And at the end, we got a combined decision, a combined analysis of both data together. This is why we have designed the navigation tree of the system to cope with the requirement of the computerized maintenance management system that will help in future to obtain all the data from site during the electrical testing to be uploaded using the handheld devices from the site immediately through the system. If there's any Wi-Fi network, then immediately it can be uploaded to the system. In terms of asset health model design, we have designed our asset health models for different assets. For example, the transformers, we are covering different areas like the sealing visual inspection, the service visual inspection, dissolved gas analysis, quality of the oil, the aging, all the electrical testing have been covered, the cooling, the thermal assessment, and the partial discharge. Each element of those have a weightage, and we call it CB1, condition parameter 1, and each condition parameter 1 is having a list of condition parameter 2. Then the aggregated health index is the weighted sum of those condition parameters. This is a second example of switchgear. Also, we cover different aspects with different weights. And the indices will be expanded to other assets like batteries, overhead lines, underground cables, terminations, with the same concept. This is a real photo from the system itself, where we can have the trends, the criticalities, the navigation tree you can see on the left side. We can create any signal trend, either gas in a transformer or partial discharge or a CB timing or a circuit breaker. We can see any trend. So we have designed the system in order to make the life easy for the asset performance engineers in order to decide for our assets in terms of maintenance and in terms of investment plans. This is the main challenge that we have faced, because not all the manufacturers having a standard monitoring signals. Also from our side, there was no a standard monitoring signals. So some of the transformers, if we have two transformers in the same voltage level, they may have different monitoring signals, and integrating different monitoring signals is a challenge actually during the implementation. And availability of standard monitoring system requirements, either in IEC or in IEEE or any other international standard, that also give the flexibility to the OEMs to design their systems according to their manufacturing requirements or to their customers. However, we have to have a standard requirement in order to have a standard monitoring systems across all the assets. Also, utilization of different communication protocols. Different manufacturers, they use different communication protocols. So once you come to integrate those systems, you will have a challenge in integrating different communication protocols. However, we overcome this challenge by modifying the local monitoring systems. But if you have a standard communication protocols, will not have any issue during the integration. Involvement of different engineering fields. In this project, electrical engineers, communication, SCADA engineers, even data engineers have been involved. So all the different fields of engineering have to work together in order to have a right implementation of the system. Low competitive market. We have a lack of vendors or contractors who can implement such systems. So choosing the right components, we are planning to establish a new health models for different assets: underground cables, cable terminations, overhead lines, reactors, batteries, battery chargers, earthing system, and surge arresters. So we are trying to roll out the asset health models for all our assets in order to decide and have optimized decisions as well. The second plan, in terms of asset performance tool, we are going to roll out the configuration of all 103 grid stations across Oman, either in the north or south of Oman, to have different health indices. Also, in terms of automation, we are going to automate the inspection and testing forms in order for the field engineers to use handheld devices in order to upload the data directly from the site during the testing to the system immediately. This is already in our plan. So in conclusion, OLCM is playing a big role in optimization of maintenance activities. It's saving cost actually, and we started to realize that saving in OETC. OLCM is the way for smart and accurate investment decisions. Of course, you will have an accurate decisions in terms of investment, in terms of maintenance, in terms of replacement of your assets. Standard monitoring signals and standard requirements should be in place. Or IEC and IEEE should work together to have an international standard for such monitoring systems. Challenges have to be considered during the design of the system itself. Any challenge has to be considered either during the design of the local monitoring system and for the central monitoring system as well. Vendor capability is very important to be considered during the awarding of the project. If you select incapable vendor, you will have a big challenge during the implementation. So that's all from OETC, sharing the experience of online condition monitoring system. I think I managed the time. Yeah. Thank you very much. Thank you, Dr.
Thank you, Engineer Tariq, for keeping up the time on spot. The next speaker is Mr. Barwash. I'm not sure if he joined us already online.